Alright, so this is the second part of the set theory unit. You should have already gone through the notes, the vocabulary on sets to understand some of that. There'll be more vocabulary as we go along, but you have the basics. This is going to be just talking about different subsets and how we can figure out how many subsets there are, how many subsets of certain size there are, or cardinality. So starting with, you should have the notes that go along with the video. But listing all the subsets of A. So if A has size 3, it has a cardinality of 3, then there are going to be subsets that have 0 in them. There will be subsets that have a cardinality of 1 or have 1 element. There are 2 element subsets and of course a 3 element subset. So of course the no element subset is the empty set. So if you have to list, don't forget to list the empty set. My brackets are not good, but hopefully you understand what those are, or braces as some people call them. You could also write that as the null set. Same thing. That's not 2 different sets. That's just 1 empty set. I mean, same thing. The singles are always easy because just each one of them. So there is the subset of 1, subset that has 2 in it, and of course the subset that has 3. The pairs, remember, order's not important, so having the pair 1, 2 is the same subset as 2, 1, so don't write it twice. You could have the pair 1 and 3, or you could have the pair 2 and 3. And then there's the all, complete the subset, all 3 of them. Remember, that is the only one that is not a proper. The rest of those are all proper subsets. So that's 1. There's 1 of these, 3 of these, 3 of these, and 1 of those. So altogether, 6, 7. There are 8 subsets for a set of 3 elements, and then listing them out same way. Alright. So W, X, Y, Z has 4 elements. So if there's 4 elements, there's going to be the 0, maybe singles, doubles, 3 elements, and of course the 4 element subset, the one that's not a proper set. But if you notice up here, each time if you have 3 elements, then if you have one subset that's 1, then you have to have a subset that is the other ones that are left out, right? 2 and 3. If there's a subset that's a 2, then there has to be a subset of 1 and 3. The other 2 things are left out. 3, so there's a 1 and 2. So every time, like if you have an empty set, then there has to be a matching set with everything. So every subset has a partner. It's called its complement. So if we start listing, I'm just going to do the empty set with empty braces. So if there's 1 empty set, then there has to be 1 subset of W, X, Y, Z. All 4 of them. There will be 4 singles. There will be a W, there will be X, Y, and Z. There are 4 single sets, so there have to be 4 triples. If W is by itself, then there must be a triple of X, Y, Z, leaving W out. If X is a single, then there must be a triple without X, W, Y, Z. If Y is a single, then there is a W, X, Z triple. And if Z, then there's a W, X, Y. And again, those are called complements of each other. They're everything. If you put two complements together, you get the whole set. Now, since there are 4 items, then the doubles have complements of each other. So if you have a pair, W and X, then you have to have another pair that are the other two, the Y and the Z. If you have a pair with W and Y, then you have to have a pair with X and Z. Squeeze them in, but there's also the pair of W and Z. So since there's 4 things, there have to be 3 pairs that contain W, because W could be paired off with 3 people. So there must be 3 pairs that contain X, 3 pairs that contain Y, 3 pairs that contain Z, but some of those overlap. So if you have W, Z, then we have to have a pair of X, Y. So each possible one has a pair. And like I said, W has to come 3 times. 1, 2, 3. X has to be there 3 times. 1, 2, 3. Y has to be in there 3 times. 1, 2, 3. And Z. 1, 2, 3. So all of them, all 6 of the pair, or the 2 element subsets, are listed. So if there's one of those, 4, 6, 4, 1, that is 5, 11, 15, 16 subsets for 4 elements. All right. Oh, we've got 16 subsets for 4 elements. All right. So, given the set C equals Bobby, Cindy, Jan, Peter, Marcia, and Greg, how many subsets have a cardinality of 1? Well, 1 is pretty simple because it's always the number of elements. So if there are 5, 1, 2, 3, 4, 6 people, then there must be 6 subsets that have a cardinality of 1, right? So for each one of those, the cardinality of 5, there must be 6 complements, 6 subsets of cardinality 5. 2s. Well, when you start getting into pairs or more than that, that's why it says at the top, combinations. Anytime you can figure out the number of possible subsets by using a combination. If you have 6 elements and you want to choose 2 of them for a subset, then it goes back to that choose. That's why we did the combinations in the last unit. How do we figure out what 6 choose 2 is? Well, put in your calculator if you want, or just remember 6 choose 2 is 6 times 5 divided by 2 times 1, or 30 divided by 2. There must be 15 subsets with 2, so there must be 15 subsets of 4. And we talked about this earlier. 6 choose 4 is equal to 6 choose 2 because 2 and 4 add up to 6. Choosing 2 to be in one subset means you're leaving 4 out to be in a complementary subset. So if you wanted to multiply that out or do it in your calculator, 6, 5, 4, 3 divided by 4, 3, 2, 1. 4s and 3s would cancel out, and it's 30 divided by 2 again, or 15. So 15 of each. Well, if we have 6 elements, then the 3, since that's half of them, are split up into complements. So if you do 6 choose 3, which is 6, 5, 4, 3, 2, 1. 3 times 2 on the bottom is 6. That'll reduce out, so the answer is just 20, or doing your calculator. But there'd be 20 subsets that have a cardinality of 3, or 23 element subsets. But since that's half of the group, 10 of them would be the complement of the other 10. They would pair off. just like we did with the 2's in the last one. And of course, how many subsets have a cardinality of 0? Well, 6 choose 0. Remember from combinations, that equals 1. And how many have a cardinality of 6? Well, 6 choose 6 also equals 1. Or we know there's one empty set, and there's one complete set, or there's one that is not a proper subset. Alright, so those you can figure out anytime if you know the cardinality or the number of elements of the regular set and you want a certain cardinality for a subset, just use a choose. So, alright. Next page, example 4. Using those, how many 4-element subsets does a set of 10 elements have? That's just 10. Choose 4. You could calculator or 10, 9, 8, 7 divided by 4, 3, 2, 1. The 4 and the 2 make 8. 3 will reduce that 9 to 3. And then 3 times 7 is 21 times 10, 210 4-element subsets, which means there would also be 210 6-element subsets. How many 6-element subsets does 13? So that would be 13 choose 6. I'm going to be lazy. You can do this on Desmos or get out your calculator. But 13 math over to probability, choose 6 is 17, 16. So there would be 1,716 subsets that have 6 elements in them if you have 13 elements. And then of course 7 would be the same thing. How many 3-element subsets does 21 elements have? 21 choose 3. 21 choose 3 is 1330. Alright, so pretty simple to figure out the number of subsets of a certain cardinality. So going on to number 5, how many subsets or list the subsets? Well, if it's an empty set, there's only one subset, the empty set. And the empty set would be the only one that doesn't have a proper subset because it's the only subset. If you just have one element, then there are actually the empty set and then everything. So there are 2 possible subsets. And with 2 elements, empty set, the singles 1, 2, or 1 and 2 together. There are 4 subsets. So 1 of those, 2 of those, 4 of those. So if we go back, there were 8 and then 16. Then we could add all of these up. 6 and 6, well 15 and 15 is 30. Where are we, down here? 15 and 15 is 30, plus 12 would be 42, plus the 20 would give you 62, plus 2 more is 64. So there's 64 total subsets if it has 6. Well, let's look at that pattern. I'm going to write it over here. Has nothing to do with these questions. But if a set has 0 elements, then the number of subsets is 1. If a set has, you can see that. If a subset has one element, like down here, then the number of subsets is 2. If there's 2 elements, the subsets is 4. 3 elements, we said the subsets was 8. 4 elements, 16. We didn't do 5, but maybe based on the pattern you can see 1, 2, 4, 8, 16. That's right. 32. And then 6 we said was 64. And we could probably get 7 now, which you can see it's just doubling, which is 128. Well, there's a formula for any number. If there are n elements in a set, then it's 2 to the nth power. 2 to the 0 is 1. 2 to the first, 2. 2 to the fifth, 32. So anytime you ask for total number of subsets, 2 to the nth power. Well, I think that's a question on your worksheet coming up. How many subsets does a set with a cardinality of 9 have? Then you're just going to do 2 to the 9th power, put in the calculator. Now if it says how many proper sets, don't forget that you have to take off that one subset each time. Proper subsets are always one less than total subsets. Okay. You may have heard of or seen before, but all of this leads to Pascal's triangle. And I don't know if you haven't seen it before, here's how it works. The top row of Pascal's triangle is called the 0 row. And that's important to remember because it tells you how many possible subsets that an empty set has, and that would be 1. So the first row, or row 1, is the number of subsets for a 1 element, and it's split up into possibilities. So if there's 1 element, there is 1 empty set, and then there's 1 set of all of them. Row 2 of Pascal's triangle tells you that there is 1 empty set. We can see it up here. 1 empty set. So remember, this first column going down to this first diagonal are the number of empty sets. And then the number of single, the number that contain 1, there were 2 of those, and the number that contain 2, 1 of those. This row is all of the non-proper sets, or the subsets that are the everything. Right? Row 3 of Pascal's triangle. Of course, there's 1 empty set. And going back to our 3 elements, we had 1 empty. Back up here. 1 empty, 3, 3, and then 1. So there's 1 empty. There are 3 singles, 3 that have 1 element. There are 3 that had 2 elements, and then 1. And of course, if they're complements, they have to complement each other. 1 empty, so there's 1 everything. 3 singles, so there are 3 doubles. Now on the even rows, they have the 2 in the middle because the complements pair up with each other. So that would always have to be an even number, so you can split it up. So row 4, going back to our 4 elements, we had 1 of those, 4, 6, 4, and 1. So there's 1 empty. Of course, there's 4 singles because it has 4 elements. There were 6, and then 4, and then 1. Well, as you keep going down Pascal's triangle, you don't have to look back at the number. I don't know if we even did 5, but if you're at row 5 of Pascal's triangle, it will always be 1 to start with, 1 empty set. And you can see this pair, you could add, these 2 numbers could add together and give you 5 of the singles. 4 and 6 add together to make, there'd be 10 there. That 6 and that 4 make 10, 4 and 1, 5, and of course 1 on the end. So the 1 empty, the one with everything. 5 would have 1 element, so 5 would have 4 elements, right? 10 have 2 elements, and 10 have 3. So when you're counting across Pascal's triangle, it's always empty, single, 1, 2 element, 3 element, 4 element, 5 element, row 5. So row 6, 1 empty, add them together, 6 that would have 1 element, there would be 15, which is what we got here, right? And that's another thing about Pascal's triangle, that if we didn't have all the rest of this to add, we could look at row 6, the third one over, remember that's 0, 1, 2, has to be 6, choose 2. If we did 6, choose 2, we'd get that 15. Add them together, that's 20, or 6, choose 3 is 20. Add 15, 6, choose 4 is 15, 6, 1. And you can continue, and I think one of the questions on your assignment is to continue 7th row of Pascal's triangle. But it's that simple. And it gives you all the possible subsets. And then, like this table, if you look across, that's one total subset. That's supposed to be an arrow, sorry. This, row 2, gives you 2 possible subsets. Row 2 gives you 4 if you add them up. Row 3 gives you 8. Row 4 gives you 16, 32, 64, and so on, which of course this is 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and so on for the total number of subsets. So all the questions just about subsets and the total number of subsets, or how many subsets have a certain number of elements, there is an assignment, subsets, combinations, and Pascal's triangle. There are 17 or 14 questions that go along with this video, and yeah, let me know if you have any questions. Sorry if you didn't see that at the end, but there it is. All right.